Recent advancements in 3D perception systems have significantly improved their ability to perform visual recognition tasks such as segmentation. However, these systems still heavily rely on explicit human instruction to identify target objects or categories, lacking the capability to actively reason and comprehend implicit user intentions. We introduce a novel segmentation task known as reasoning part segmentation for 3D objects, aiming to output a segmentation mask based on complex and implicit textual queries about specific parts of a 3D object, for example, knowing where to hold a kettle or which part of a bottle to open in a fine-grained manner. To address this challenging task, we propose PARIS3D, reasoning-based 3D part segmentation, a multimodal large language model capable of reasoning on user input text, predicting 3D part segmentation masks, and providing explanations for the model's response. To validate the effectiveness of PARIS3D and support future research, we establish an evaluation benchmark and a dataset named RPSeg3D for reasoning 3D part segmentation. Our RPSeg3D dataset comprises 2,624 3D objects and over 60K instructions, providing persuasive evaluation metrics for the task. Simple templates are provided to GPT 3.5. Which populates them with part information-related segmentation instructions. In parallel, color, shape, location, and dimension-related data are extracted from 3D point clouds. Enriching the instructions with this information and manually checking them for inaccuracies, we obtain the RPSeg3D dataset for part segmentation. Overview of the proposed reasoning-based 3D part segmentation approach named PARIS3D. It comprises of 4 subsequent steps. First, the 3D point cloud is rendered into K multi-view images using a renderer. Second, these images are passed through a frozen vision backbone and multimodal large language model of the reasoning module. The multimodal LLM also accepts the text query and produces text outputs corresponding to each view. Next, the decoder decodes the final layer embedding which contains the extra token, thus producing K-segmentation masks. Finally, a mask-to-3D segmentation algorithm lifts the projections back into 3D and a view-guided scoring module is used to obtain the final text response. Our reasoning part segmentation results show that when fine-tuned with 3D information, our model performs better than the baselines for normal and 3D prompts. Upon 3D semantic segmentation comparison with existing models, our method has better performance than methods that use the explicit names of parts. We provide examples of PARIS3D output for 3D object part segmentation tasks. PARIS3D is capable of segmenting fine-grained details in categories like buttons of a remote or legs of an eyeglass from implicit queries that expect it to do self-reasoning to generate the right answer, and then segment the part. Moreover, it can perform tasks like object description and question answering with regard to object parts and give detailed answers. This demonstrates its conversational, reasoning, and part segmentation capabilities, as demonstrated in these examples. In this work, we introduced a novel challenge within 3D segmentation, reasoning-based part segmentation and a dataset for this task, RPSeg3D, to enable effective evaluation. We believe this dataset will play a crucial role in fostering the growth of technologies in this area. Our pipeline integrates 3D segmentation capabilities into multimodal large language models, and our model, PARIS3D, exhibits competitive performance. It additionally demonstrates the ability to identify part concepts, reason about them, and complement them with world knowledge.